So we have come to the end of the inaugural function. Now we are starting with the sessions that we are having today. For the first session, we are having our speaker, Shri Vasant Meharkure sir, who will be delivering his speech on need of materials on sustainable development. Shri Vasant Meharkure sir has more than 35 years of experience in mechanical, metallurgical, chemical, and non-destructive testing across 4 central government ministries. His major expertise are in failure investigation and material testing to control quality in manufacturing railway coaches. He has completed metallurgical engineering from COEP in 1986 and diploma in business management from Chhatrapati Shahu Institute of Business Education and Research, Shivaji University in 1992. He has started his career as metallurgy investigator in 1987 in Small Industry Services Institute in Phal, Manipur till 1990. He has joined Field Testing Station Kolhapur as Small Industries Promotion Officer in 1990 and continued to serve till 1996. He has served Ministry of Commerce as Scientist B from year 1996 to 2003. He has served Ministry of Consumer Affairs, Food and Public Distribution as Scientist T from year 2003 and to 2009. He was Deputy Director and Principal of NDT Training Center at Research, Design and Standard Organization, Lucknow from year 2009 to 2014. He was Deputy Chief Chemist and Metallurgist at Integral Coach Factory, Chennai from year 2014 to year 2016. He was Deputy Chief Chemist at Metallurgist at CR Loco Workshop, Parel, Mumbai from year 2016 to year 2022. From Cummins College of Engineering for Women, Nagpur, we welcome you, sir, for this session. I request Meharkure sir to kindly speak for the session.
Thank you for giving this introduction about my personality experience. I thank you, Principal of this institute, for giving me a chance to share my experience in this seminar, which is for your teaching staff as well as scientists, PhD fellows, ME, all over India. This is opening session. Here I want to share my experiences, whatever I have gained during this 35 plus 2 years in private organization. I was working in Nashik and Nagpur after my graduation, and that too in foundry. So everywhere what I have seen, the topic it is given material, but what material it is explained that's which can sustain in sustainable development. Need of the materials. So it may be automobile industry, electronics, it may be mechanical, it may be electrical. So everywhere we are using these materials. Materials are maybe metallic, maybe non-metallic, maybe this you can separate that composites, ceramics, polymers. Lot of materials are there, but common factor, if you will see the characteristic of the materials, so you will come to conclusion after seeing the characteristic that all materials having dissimilar characteristic. Majority are having the similar characteristics, but even non-metals are having some properties which are matching to metallic materials. So
you can use your slider. PPT. Just a second.
Left, na? Hmm. तुम्ही बदला. Sorry, we will continue now. First slide. Next. So, I cannot read now. Zoom kar.
Can you see this laptop there?
लॅपटॉप असलं तर म्हणजे बोलता ते कारण तुम्हाला
तो laptop आहे.
हा म्हणजे इथे असला तर असं चला. Sorry friends. So, sustainable development is a kind of development that fulfills the basic needs of the present generation and also preserve the natural resources of the future generation. Earth has enough resources to meet our present and future needs for development if we use them economically. Then what is the need of this sustainable development? So first and foremost is to preserve the environment, to protect biodiversity, third to mitigate climate change, fourth to eradicate poverty, fifth to promote social inclusivity, and sixth to foster long-term economic growth. Next, what are the pillars of this your sustainable development? So next slide. Next. So first and foremost is environmental. Why we are switching over to materials? We are always keeping changing. We are trying to find out new solutions, new materials for the environmental thing. Means to protect our environment. There should not be pollution. So our atmosphere should not be polluted. Second, social. That is also for social development. And third is governance, means the government, whatever the laws they are making in favor of this sustainable development. Key characteristic of sustainable materials: when we are using these materials, we are switching over to other materials. We are finding out the new materials like nanomaterial, biomaterials, and functional materials. All sorts of materials are coming. People are getting confused. So what you mean by all these functional, green materials, nanomaterials, and energy stored materials, all these terms we are using, that is non-engineering people, they are getting confused because of this. So I want to make it very clear here. Materials may be metallic, that is one may be ferrous or non-ferrous, and non-metallic materials may be composite, may be polymer. Now this green material means earlier we were using bamboos, mud, bricks, like that only. Biomaterials, biodegradable materials. It is a different properties as per our requirements. So this special characteristics means made from the renewable source, enable recycling, it is non-toxic and biodegradable. The materials now we are using, materials means metallic materials we are using. So even that metals, some elements are poisonous, like arsenic is poisonous, but arsenic we are using as an alloying element in ferrous as well as non-ferrous materials. Cadmium, lead, and mercury. So we have to take care nowadays that these 4 elements we have to avoid. We have to try our level best. Earlier we have developed with these elements lot of alloys. Even if you see, if you will check the water, you will find this arsenic content. In environment, this cadmium, even lead, we are using for pencil. For earlier that for toothpaste tube. So already from years together we are changing all this. We are using very less now. This content negligible. Nowadays, government is also taking care of this. That's why we have said that one pillar is governance. They are taking care of this, that our environment should not get spoiled because of this. So this new terminology here as a material, new material we are talking about. Once I have gone through this, and there was a title that whether these new materials were dream or nightmare. What will happen that with this one? So mostly health industry I would say that even neurosurgery, orthopedic surgeon, they are using this cardiologist nowadays stent of this other materials. You can say that biodegradable. Earlier metallic stents they were using in cardiology. So metals cannot be replaced by non-metals and other new materials. It can go parallel as per your technological developments, electronics or IT industries. Whatever you are required, very small, what you can say, capsule should have much more energy than that of your voluminous metallurgical containers. That things we have to take care of this. So they are not finding out the replacement. Now that for storing the energy, very big flywheels we are using. For having the more strength, we are using very big components. Now, because of the development of this better alloys, combination of alloys, so we have reduced that weight of the required component. Some people they are arguing that per capita consumption of the metal has been reduced. Per capita reduced because of the new invention in the compositions that in alloys. Better and better alloys we have introduced, we have discovered. Every day now and then, just like this, your new nanomaterials, this and that. From the years together, metallurgists, mechanical engineers, those who are involved in the metal study, material science study, they are introducing new alloys. If I am not wrong, as on date, more than 70,000 alloys are there in the industries. Maybe ferrous alloy, maybe non-ferrous alloy. So from that 70,000, whatever the requirement you are giving to the, just now suppose if mechanical engineer or electronics engineer, if they are giving their requirement as per the design, that they want this particular component having these properties. They require lot of properties in very small what you can say that take an example of piston, camshaft, gear, whatever, voluminous gear not required. They will give the geometry that way. And they will ask metallurgist, can you give me all these properties in a small by reducing the weight? Fuel efficiency in our automobile industries. Your weight of car not reduced only by non-metallic or nanomaterials or biodegradable or other or composite or polymer, but even they are having metallic, what you can say that metallic component has reduced.
Excuse me, sir.
And because of reduction in the weight.
Excuse me, sir.
Of the fuel.
Slides are not moving, sir. Please change the slides.
Next. Okay.
Sorry, sir.
Just a minute. First. Next.
Okay, now it is moving. Yes, yes, sir.
No. Earlier you take previous. Next.
Yeah, from this slide you have to please.
You can read, no? Materials are used in almost every aspects of our lives, including transportation, housing, clothing, communication, food production, etc. Materials are chosen for their special properties such as strength, durability, flexibility, and weight. Understanding materials is important for design, manufacturing, research, and whatever we were discussing about this development. As per the requirements, we have to innovate. I can say that we have to discover the alloys, which will give the satisfaction to the design engineer, to the manufacturing person, to the for the development of this. Okay, so after all, the selection of the material, whether he is a design engineer or he is a failure, what you can say that to find out the faults with material, quality control department, they are trying to have the answer for their failures. When we are introducing some components or replacing the component, design engineer is giving and the performance is not good. Already everything has done. Already they have tested all this material, but expected life, suppose that component will give 20 years of life, but it fails within 2 years or 5 years. So we have to have detailed study on failure, why it fails within 2 years. While going through that failure analysis, we are getting the answers for, so we have not to change the design, we have not to replace the material, but we are wrong somewhere. That is the failure study. But while selection of the materials, we are having whatever the material types, we are having the basic test based on the physical properties, based on the characteristic of the materials. Even what I said that 70,000 materials are there. So while enable accreditation, when you have to offer your scope, that time I had offered in ATS to 54 products, but I have studied 650 specifications published by Metallurgical Department in Bureau of Indian Standard. So not more than 17 tests were there, common. So covering that 17 tests, we were going to cover 650 components. So we have to first understand what are the characteristics of the metal. So characteristic of the metals means properties of the metals. From that properties, we are getting the information. Design engineer, on the basis of that requirement, he will give the specification for the component. He will define basic test, that tensile strength, hardness, impact strength, fatigue strength, shear, creep, whatever the requirement. If they are going to use in where temperature is more than 400, 500, just missiles or rocket or even some heating elements, they are using the. So they will give the proper specification for that one. So we have to find out which material will meet the requirement. It has taken care of as a design engineer, they have taken care of. Here I have given the list of type of materials, so many materials, but I will stick to metals and alloys only. Next slide. So these are the properties of metals and alloys. One or near about 20 to 24 tests are there. Specific gravity, specific heat, elasticity, plasticity, stiffness, ductility, malleability, hardness, tensile strength, toughness, shear strength, machinability, resilience, impact resistance, fatigue resistance, creep resistance, brittleness, porosity, weldability, fusibility and fluidity, thermal conductivity, electrical conductivity, magnetic property, refractoriness. So from this test, design engineer will select two. Suppose powder metallurgy product is there, which is the most important test for powder metallurgical products, self-lubricating bearing, suppose. So that material you should have porosity when they are using the powder compaction sintering. So we are going to test that porosity property, how much oil will retain in that pores, and it will give the self-lubrication. So that test is very important for the self-lubricated bearing. Specific gravity and specific heat, everybody knows basic material, they will specify the elasticity, plasticity. That if you see the stress strain diagram of mild steel, you will find that straight line, it will obey the Hooke's law. Therefrom, you can calculate. Here I am going to cover with this basic test why we are conducting the test to evaluate these properties. Somebody will see all these properties are required. So basic knowledge, the people, those who are involved in the field of engineering, even electronics or IT engineer, he should at least know all these basic requirements of the material, and that material possesses these basic properties. And for that properties, what is the test? Means whether it is mechanical, whether it is chemical or performance, whatever it may be. That mechanical testing will evaluate these physical properties, right? And what for we are conducting the test, mechanical test, we must know what is the significance of that test. Only for the sake of satisfying that specification, whether it meets the requirement of that specification or not, that we are going to see, because that specification has been formulated by the experts. By maybe Indian standard, that is Bureau of Indian Standard, they are formulating the specification. They have formulated more than 17,000 specifications till that. So for every product, every test, we are having the standard test methods formulated by Bureau of Indian Standard. Formulated by, they are having their own committees. For formulating this test, they are having metallurgists from your private organization, this, and then I was one of the member for that one. Material testing was earlier, means when I was in the government organization. So that time, 4 or 5 committee I was covering from railway, from that national test house. So all experts are sitting there, those who are in the field, those who are performing the test, those who are using the components, those who are manufacturing the component, and those who are the consumers. Suppose if they are having the specification for pressure cooker. So for pressure cooker, there will be an expert from the manufacturing department, from quality control, from government organization, those who are having the policies and laws, and from the consumer side also. Then only they are formulating this, and they are publishing the specification. Likewise, to carry out all these tests, our Bureau of Indian Standard, they have published the giving IS 1608. IS 1608 for tensile testing, things like that. IS 1500 given for BHN to carry out the hardness test as a Brunel hardness number. So every test they are having the specification. Some tests are there which is not a basic test. These are not, some tests are not a basic characteristic of the material. Just like your units, kg per meter square, mm square, centimeter square, or pound per square inch. Now SI units are introduced. Internationally, they are accepting this one. Your accreditations are there. Earlier, some people, they were giving the results in pound per square inch. Then MKS system was there. Then CGS were there. Now everybody should go for SI units. When I was in MKS in 2005, they have insisted you change dial of your universal testing machine. It should be in Newton, not in kg. So that was the development here in the test. So this 24 or 22 tests we are taking care of one by one. I will describe. The basic tests are there: tensile, hardness, impact test. Impact we are having ISO, CHARPY test. Grip test is there. Fatigue test is there. Fracture toughness. So what is the significance of this test? These are just like a refractoriness. It is nothing but to see the resistance to temperature, means ceramic materials, that whether it withstood whatever the required temperature or not. That test will be carried out as a magnetic property. Suppose magnetic material you are going to use. So magnetic parameters will be there. Electrical for conductivity, resistance you are going to measure. For that thermal conductivity, same thing again, that conductivity of the material. Even you are applying the paint, you will see the conductivity, thermal or electrical resistance is there or not. These are the tests which are carrying out to see the performance, not basic, means characteristic. What for the, we are going to use that material, means coating material is there for resistance to heat, 5 degree, some paints are there, 5 degree can be reduced. Sun temperature is 45, so now your roof will be reduced 5 degree. So that paint. So for that we are having additional, like weldability, only you are going to see the weldability of the material, right? So such type of test, these are the product tests as per the requirement. But basic, your tensile test. One tensile test, all mechanical engineers everywhere, all students, all number. Next, let me discuss about other tests of the properties of ceramics: refractoriness, refractory under load, dimension, stability, thermal conductivity, resistant to abrasion, thermal spalling, chemical resistant to corrosion, texture. Next, polymer, tensile, elongation at break, rapid retraction, water absorption, swelling in organic solvent, tackiness, useful temperature and chemical resistance and elasticity. Next. So these are the, if you will find out, these are the whether it is ceramic, whether it is composite, whether it is polymer, or whether it is material. Basic test near about the same. That you have to study. If what I am saying that more than 70,000, I have learned about that 70,000 specific compositions are there. Means materials are there. 70,000 we are using plus 70,000 plus. Okay, but what it is? If you are a metallurgist, you will find out it may not be more than 40 or 50 compositions you have to study. And one or the one things is just you take that brass, normal brass, and some basic. So 70-30 composition will cost more, and 63-37 basis brass will give cost less, but giving the same result. Giving the same result, whatever the requirement of the scientist or your design engineer is fulfilling by low cost material, then why we are not going for that one? Because of ignorance, very blindly, once upon a time, there was a combination of these alloys, 70-30. So blindly we are giving order to 70-30. Just take an example of stainless steel in railway. I am not specifically on railway, such a big platform. Where, so that specification 70 years old, 50 years old, 30 years old, because we are making our own specification just like the Bureau of Indian Standard. So always we are updating that one. Somewhere we are not using that material. Nowadays, suppose new materials are coming, so old, but sometimes we have to use old one. It is not upgraded, it is not revised, it is not reaffirmed. So then user what will do? Same specification they will mention. Such type of things are happening everywhere, not in our organization. Everywhere it is like that. When we are literate people, we know we are having such a vast knowledge in the field. The person like me, the 35 years I have worked, but I am not extending my knowledge to the people, those who are involved now in this. You revise this specification, you should have this amendment. If I am not telling the people, means those who are coming, new generation, then what's the use of that experience? That I want to say. So these are the mechanical properties, these are the basic, that is strength, ductility, malleability, hardness, creep, and fatigue. Earlier, I have given that 22, 24 list of the test. Now, these are the basics. So, tensile strength means what are the significant? Now, we are going to see the significance of this test. Interaction. Now, suppose if I have to interact with the people, I will raise the question: what is the depth of knowledge are having the participants? Suppose if I say something, so I should get a response from just like your classroom. If they are very innocent, they are student. But here participants are more than 100 and 150. They are more than that of knowledgeable than me. If particular in the particular field they are involved, means they are having what is the vast knowledge. Depends on their exposure. So strength, the tensile strength, if you go for that graph, how many tests you can, how many parameters you can evaluate, how many, what you can say that your requirement by conducting one test only. Like suppose rubber, polymer, ceramic, all sorts of material. For ceramic or composite, you can go for compression test. Compression test can be carried out on UTM. Tensile test you can carry it out on UTM. Hardness test you can carry it out UTM with the special attachment. Only compression load you have to apply. You should have the ball, and you have to measure the diameter of the ball, diameter of the indentation. From that formula, you can calculate the BHM. Likewise, shear attachment is there, so you can have the shear. You can have bend test. You can have rebend test. So many tests, because basic axial loading you are going to apply on the component. So from one machine, you can extract the information whatever you want. More than 60% of the information you will get from that one test only. You will plot the graph. You take structural engineering, your building materials, your TMT bar. TMT bar, people they are using. Even engineers, those who are not involved in testing, those who are not involved in, even quality managers, they are not aware about the things happening. I will say like that. That is not their fault. Because technology is developing. Once upon a time, your building material was not having the serrations. That this one. Now serrations are there. Lot of changes had happened. Earlier, strength was improved because of micro-alloy steel. Then cold roll passes they were giving. Nowadays, they are giving the pinching. Pressurized pinching. Steel Authority of India Limited, they are manufacturing very blindly people. They are paying more money, 30-40% than that of other re-rolling mills. But for that technology, because if you will take the microstructure of that TMT bar, you will get ring just like an induction hardening, flame hardening. But that ring should not be having the martensite in that one. So that pressure, particular pressure, will control the transformation of the phase. Instead of transferring to martensity transformation will make a brittle material. It will crack. It will not sustain the earthquake. Now people they are marketing like that. Where earthquake you use our TMT bar. What for? Because outer ring is having wear resistance as well as all this energy. It can be observed. Whatever the treatment they are giving. And from that, so we have to suppose quality control manager is aware about this. What are the other rolling mills? They are quenching, but transformation is martensity transformation. It will happen. It will spoil the material. People commonly, man, if I am going to construct my building, I do not know anything. What people they are doing in a jobbing test house, they will say, don't go for proof stress. Proof stress is the things which are getting out of this heat treatment, especially that TMT bar for construction purpose. Why I am putting that example? It's a common people they are using for their house. TMT bar. In the market, they will say that this one is 8,000, this one is 10,000. We will go for 8,000. Na? After all, it's steel bar. re-rolled, recycled scrap are being used, where we are not going to get that, because adulteration through paint or everything, or gradation of that material, recycled scrap, it will not proper, ingots will not be this one. So all micro alloying elements will be there, just like that arsenic, that bismuth, that like this materials will be there, and it will spoil the property. And if it is not properly this heat treated, that TMT, you are not going to get the proof test. Why I have explained these things in this graph, when we have to plot the 0.2% proof stress. That time you are plotting the graph. Nowadays machine having all these attachments, and on machine itself you are getting the graph. You are getting the proof stress. All calculation is done by the, but calculation is done by the machine. But machine goes wrong somewhere. You should have a basic knowledge of that. By comparing, you must in a position that is to say, no, these things are not happening. Something is wrong in the machine. That much of information you should have basic as a mechanical engineer. As a mechanical engineer, somebody is telling that, okay, sometimes it will give more proof stress, but it cannot go beyond that. There are cross checks. So experienced people are getting this information through conducting the laboratory test. And if they are discussing all these things, so people will, means people, those who are involved in the quality control, those who are the design engineers, those who are using the materials, anywhere. Why, what for they are paying? If they know what returns they request. So this one tensile strength, you are going to get yield point, yield strength. While manufacturing, if you have to select the proper manufacturing processes, you have to exceed the yield point, that much of load for rolling you have to give. You will get the idea about how much force you have to apply for rolling. If you are going to use as a beam, it should not get deflection. So that deflection load application should be less than that of yield point. Same thing happen with that proof stress. Where you are not getting the yield point, you are plotting the proof stress. That is either 1.1% or 0.2%. Ultimate tensile strength we are calculating, that's the maximum load. That's the maximum load you are applying. And from that you are getting the ultimate tensile strength. Breaking, fracture toughness, where it breaks. That time if you are going to measure breaking load, it will come less. But if you are going to plot the true stress versus strain diagram, it will reverse, because your tensile strength is load divided by area. At breaking stage, your area will be very less. So if you divide with that area, that graph will not come down. It will go up. Right? So these are things we have to understand. So then this ductility. Ductility is a parameter. For that we are calculating the percentage of reduction, percentage of elongation. You are going to get the ductility clearance. More elongation, percentage elongation, more ductility will be there, more malleability will be there. We can at least reduction of area, more malleability will be there. So these things are getting. Then hardness. Earlier tensile tests were not conducting. Earlier 100 years or like that years. So they were conducting only hardness. From that hardness, they were calculating the tensile strength of the material. Means putting the condition for normalized material, this will be the reduction 0.36, 0.32 or 0.36 multiplied by VHL is equal to kg per mm square during those days. Now we are having advancement in the technology. Machine suppliers, they are supplying the machines. Earlier specification, even Indian standard specification, they were giving the specification that how to apply the load. How to apply the load. They in IS 1608, it is clearly mentioned 5 to 15 Newton per mm square per second. If you will ask the test house person, nowadays all are enabled accredited, and these were NCs 15 years back. Now people are knowing, but common those who are not exposed to this, those who are not a testing personnel, they are still not aware about this one. why they are giving this rate of loading, and if it is given, how to calculate that our rate of loading while opening the valve, oil valve. Load application that your digital readout will come this and how to. Now some machinery they are supplying rate of loading also can be measured on the machine itself, because work hardening material, if that exceed the limit of that rate of loading, it will stain harden, and stain harden means you will get a very wrong information after result. Material getting stain harden means your strength will be more, elongation will be reduced, and you will get a wrong information that your material having this much of elongation, that will be very less than that of specified, and your strength will be very high. And material composition is same thing. Whatever it is specified, composition is same, but your properties will, because of the error of the testing personnel, since he has not followed the rate of loading given in the specification, or that is the ignorance of that operator. That's why, if now slide will come, that benefits of accreditation, what benefits we are getting. Earlier, those who were expert in the testing, suppose if I have worked for 10 years, so I was considering myself that I am experienced holder, I know everything. And new people, those who are coming for testing, new assistant, new technicians, so they are not aware about this. Only they have to replace the jobs, and they have to assist testing personnel. So this things should not happen. That's why earlier test houses, government especially, government test houses, those who are termed as a scientist and they were working for. In private organization, matriculate person were conducting the test earlier. And we people, after getting the degree in science, MSc in science, PhD in science, after graduation in engineering from NIT, IIT, selection through UPSC as a scientist, they are doing the job of testing. I was doing with my own hand. Why government is paying this much of money? Because educated or degree holder or whatever the qualified person having the vision of that, while applying the load, he will refer the specification, he will try to understand what it means, why it is written. If I am not getting that information from specification, it is written, but I could not interpret the thing, though I am graduate engineer. So I will ask some seniors, sir, what it means? Or at the last, we will go to Bureau of Indian Standard. What do you mean by this? You tell me. He will explain the things, and such type of things will be avoided. Because of ignorance,
Divla,
results.
chora bana ne.
Next. So, and without help of this, again you. Next, yes.
Zoom it.
Achha. Mechanical test may use to qualify materials for their service requirements as well as for determining the normal strength properties. Typical mechanical properties of metals and alloys are strength, what we have discussed. Ductility, then creep. Creep is a temperature sensitive. At a particular higher temperature, you are using them, and for that, testing setup is there. For fatigue, your automobile components, just like a shaft, all of a sudden it will fail. Number of revolution is more, and your what you can say, that endurance limit is not known. Your design engineer has given this much of revolutions, it can sustain. Means in the number of years, they will say that 25 years guarantee for this axle. But sometimes it may happen after 15 years that axle may break. It happens in railway. Sometimes axles are broken. Sometimes wheels are broken. Very big accident, manpower losses, death. You have seen that. You cannot compare that losses in terms of money. Money involved. Your what you can say, that rail, these, that, so many, they means they are not in a position to use that way for particular to and fro motion for the other trains. But suppose people are dying, what will happen? So it is a regular feature for any, even automobile industries, it happens, but it not comes in. we are in railway or other big organization, we are having the statistic. We are having all these records. We are finding out. It is our duty, prime duty, quality control, quality assurance, statisticians, they are having how many axles we have used, how many axles are in use. It's the compulsion for ultrasonic testing, 100% ultrasonic testing. That ultrasonic testing, 100. So suppose if accident occurs, immediately from that axle punching, they can find out from where it was tested in railway throughout India, and immediately they can take action immediately on that operator. Operator is qualified, MSc or B.
2 days before that Dhamangao railway, because of hot axle, the
Correct.
one of the train has been stopped and the passengers have been evacuated.
Yes. So such type of thing, that is what I want to explain. Such type of things are happening not deliberately. When it comes to me, I am from testing. I was reading in railway for Central Railway. Earlier I was in RDSO. RDSO, that is the research. There we were formulating the specification for this one. Bureau of Indian Standard, they are having the specification. But for railway, for our own product, we are giving the counter specifications, adjunct specification. For tensile, you refer IS 160. For hardness, you refer IS 1500. But some test, we are putting that specification, we are preparing ourselves. Means performance, for performance or for other counter checks, we are having the specification. For a new component, for assembly, for casting, we are having our own specification. So that statistic we are having, number of axles, number of wheels, and it comes to laboratory. Where laboratory, I am having that report, one report to explain all this thing. So we are getting the information. Suppose your knuckle sometimes deactivate, that coaches or wagons are right now split. So because of that knuckles, it's a casting component. All specifications are made because whatever the store comes in railway. So we are having very foolproof system. It is tested by RITES, autonomous organization, very big organization, and they are testing all these materials. They are passing it. Then it will come to railway depot, means store, and it is being used. What is our role? Suppose after getting all this information, they are having the testing certificate. It has been issued by the private industry calibration testing laboratories, that to accredited laboratory. Nobody can raise their finger on that laboratory because internationally it is accepted from that laboratory. Then what it comes on shop floor itself, the person who uses that component, he will say, sir, these are the problems with this component. Take an example of screw. He will say, screw head is breaking. Threads are getting spoiled after this one. So it should not happen. But what is the sampling criteria? Why it happens? How it is heat treated? And how it is tested? All these things comes in failure investigation. So before failure investigation, if shop floor person is telling like this, sir, this component or this plate is not getting bendy, while construction of coach or repairing of coach, plate is not getting, the operator means labor can assess that one. Very easily 2 persons they were bending. Now 5 persons they are trying their level best, but it is not getting bent. So they are applying load. Load means hammer this and that. When that angle of bend increases, your orange peel will start or crack will start at the radius. Means that it do not make, but it has been passed in the inspection level. Well, so that fine. So immediately we have to bring it. These are the things. It is written. Especially it happens. Immediately you have to inform store this material. You get it. Supplier this. They will replace the material. But what happens if such type of thing happen? Hot axle or spring breaks during this one. But that guarantee period and this and that, and before that guarantee, it will come for failure investigation. And if reasons are basic means do not meet the specificational requirement, then question is raised. How it has been passed by the inspection authority. And a lot of blunder will there. But majority of times what it happens, it meets the requirement everywhere, till it fails. Then it will come to how it was fitted. In the drawing, it is given that inner spring should be like this rotated, outer spring should be like, so they will not fitting in that fashion. Your contract levels are there. So many things are happening. So we should have a very big quality control checks. So I will come to that one. So mechanical testing those properties of material that are associated with elastic, inelastic reaction when force is applied or that involve the relationship between strain and stress. The test should yield the information accurately, rapidly, and economically. Next. Too frequently, the engineer is only concerned with the mechanical properties of the metals he uses, but composition, casting, shaping, and heat treatment have a tremendous effect on ultimate behavior of the new alloys. Consequently, some knowledge of metallurgical theory and practice becoming more and more essential to modern engineers. And this involves such things as microscopic examination of metals and interpretation of the structure involved. All these tests are specified in the specification, but microstructure they are not specified. And even if it is specified, they will not give the limits for that one. No limits, it's a qualitative test. That it should be, structure should be martensity. Structure should be pearlite ferrite. So qualitatively we can see whether pearlite ferrite grains are there or not. But if it is a dendritic structure, means as a metallurgist, I am getting the information by seeing the structure only. So I can assist very nicely to the mechanical engineer. I can be very helpful to mechanical engineer. Sir, here it is Widman-Staten structure, means your foundry, Widman-Staten or this dendritic structure. So properly it is not heat treated. Forget about properly. It is not at all heat treated. As fast they have removed from the box, they have cut the runner riser getting system, and even sand will be there as it is. Whatever the core they are putting in knuckles, what is happening? If after that, when knuckles are coming for failure investigation, at that time we are seeing all holes are packed because of that course.
Without decoy.
And that course shifting is there. So one thickness will be very big and one side thickness will be very less. Very less means practically going to fail. These are the things coming after breaking only. Each and every casting cannot be break. So representative of the casting that can be taken out of 10. Out of that, parameters has been decided by the means organization, user organization, whether it is defense, railway or other. They have made the specification that out of 10, we are going to send one sample for testing to any enabled accredited laboratory. They have tested that one. Luckily, it was okay. No core, no nothing. But what it happens, all other 9, if they are having this core, remain core or this core shift is there, such type of things are happening. There exists a close relationship between the structure and the properties of metals, and structure is established by the past history of the metals. Manufacturers, where imperfection, what I have discussed, every casting should be at least heat treated for relieving the stresses. Somewhere specified by the design engineer that my requirement is martensity structure hardness should be this much, and your wall thickness this, and mechanical engineer define that hole should be this. No means tolerance they will give, no compromise with this. It should be like this. But it happens, and when it is not heat treated, it is very dangerous, because after pouring the metal, when it is getting solidified, lot of stresses are developed, and because of stresses itself, your component will be failed. So they have, but what people, they are manufacturers, what they are doing, they will remove the casting. Your NECO officer, you are from NECO, na? They will remove the, it is not against you, but practical I think. So they will remove from the mold. At what temperature? Because consultant like me, if I am a consultant with NECO, what I am going to say, why you are hitting again for annealing or normalizing? You simply remove at this and you keep it in the air, it will be normalized. So at that particular temperature, whatever he has checked by digital or whatever it may be, that system will be standardized. And they are getting the information that instead of those who are giving the heat treatment, they are full. Because again that casting is hitting, normalizing. But they are not having this much of expertization or seriousness about the metallurgical points. If it happens, they have quoted the price whatever in the market. They are considering that. No? That's why design engineer of the user department, they have mentioned no? It should be heat treated, it should be normalized, this and that, and my structure should be this. So these are the things deliberately happening, or some people they are cost saving economical factor they are considering. So in fabrication also, in service by corrosion, nuclear radiation. So whatever the things are happening, we can improve the properties of the material, that is for by grain size control. If you are controlling the grain size, all these specification parameters are given to control these parameters. Grain size should be controlled. If you have a fine grain structure, that's why it is mentioned in the drawing that it should be normalized. If you want to have coarse material, big grain size, then we will say slow cooling. Annealing treatment should be there. So all this for to grain size by casting or by heat treatment. Cold working, suppose if rolled product are there. After cold working, stresses are being developed. So we have to anneal. If it is not anneal, structural steel, so again it will be having the stresses. Mechanical working, producing work hardening. That tensile test what I have number of passes means more strain hardening, and that strain hardening will give you the this hardening effect and directional properties. In rolling direction, if you will see that one recrystallization and grain growth, every passes it gives like this, and that grain growth lastly it happens if you are not hit not removed the stresses, again that material will not meet your specification as specified. Heat treatment to harden and allotropic transformation by precipitation particles. Next. Time limit. Next.
Yeah.
Next.
To
750, no? I don't. Okay, how? 30 minutes, no? Then, accreditation of laboratories. Now we have seen what are the characteristics of the metal. Specifically, we are seeing and their alloys. Okay, basic properties will be one and the same thing everywhere. This terminology, nanometer, biodegradable, so many things will come. I have seen your 6 days will cover all these things. But basic funda behind this one, your work hardening effect will not be there in the composite. But your wearing properties will be one and the same thing in the metal you require wear. So you are going to use cast iron. You want to have damping capacity. So more damping capacity material develop. So you are going to switch over to that material. Composites or polymers. So FRP, even in railway we are using FRP, fiber reinforcement. Lot of things we are also, all other people, wherever we are getting the benefits. Earlier, this brake blocks, phosphorus cast iron, means having more than 1% phosphorus, they were using the brake blocks, brake application. So 20 years back, they have switched over to composite. Now, earlier, while at the development stage, there were problem, but now no problem at all, because your cast iron, earlier they were using cupola furnace. Advancement in technology, people they have switched over to induction, and induction furnace is not good for this cast iron melting. Instant melting will not give this effect of cast iron, where nucleation, your graphitization, your phosphorus network should be there, just like a honeycomb phosphorus. Then you are going to get better and best wear resistance. If you are melting the material in the induction, all these properties you are not going to get. So a lot of things were happening, accidents were happening, brake blocks were breaking. Just you think of that one on platform, it happens. So major accidents. Yes. So that significance of the test you are seeing, why you are conducting the, and now we have to see why the accreditation is required. What do you mean by accreditation? Everybody is in the quality control. Those who are involved in the testing, majority of participants, you are suppose if they are having this basic knowledge, your even teaching institutes are accredited now. Our principal sir has told that accreditation is there. So in 90s, this accreditation starts in testing laboratories. Earlier, it was the NICTCF when I was in Kolhapur. So that time we have offered the testing laboratory having 3 persons working on what you can say that evolution of material, this and that. So we were not knowing that NCTCF council of that testing laboratories, they were not in a position to take the application. So they said that you wait for few years, it will be converted into NABL. Now it is NABL, National Accreditation Board for Testing and Calibration Laboratories. So beginning when I was in National Test House, Mumbai, that time our testing scientists from National Test House, being a government scientist, they were going without any training for accreditation, for assessment of laboratories. Our scientists, means I was new senior scientist. They were going for this one. Within 5 years, they have offered this auditors can be trained from the private institution. Now, more than 90% people are from private organization, those who are involved in testing. Now, ample auditors are there. And I will say more than 95% of laboratories or even our government organization laboratories are accredited, because NABL accreditation will not see that whether it is a government organization or this one. They are having their norms, it is described everywhere. So they will assess our capability. They will assess our capability and who has made? Automatic. So they will assess your capability, they will see the capability of the machine. All these things will be assessed by NABL. Very blindly, what are the benefits you are going to get out of this accreditation? So blindly, you don't have to see the capability of the person. You don't have to see whether that machine is calibrated or not in the laboratory, whether their what you can say store department having proper facility for keeping the tested samples, whether that traceability is there or not. So many things are happening. So once you have been accredited, means you have taken care of all these things. Earlier, what was happening in government organization, we were telling that we are from the government organization, nobody can raise the question, that nobody can see our testing facility. We are thinking as if we are bosses of all other people, and we are having a lot of knowledge and experience. But when we had been accredited or assessed by the assessor from outside, so as per clause, very politely they were telling that, you see sir, like this, here your concept is not clear. It happens with me when I was heading the calibration laboratory and testing laboratory both. And I have offered this, I had offered that time 54 products and calibration in pressure, vacuum, dimension measurement, force, all these things so they were not in a position to accept that one man can be head of all these things. It was questionable. So we said that I am the only technical head. And then you must have to prepare for this answering. We'll have questions. You tell how you are calculating the uncertainty of this measurement. So a lot of questions were raised. I was young. I was preparing for this all means answers, and I could satisfy that time. And I was heading calibration as well as testing laboratory in National Test House, where so many products and so many parameters in calibration laboratory. So this accreditation gives us the benefit. No need to see, even customer no need to see the capability. Once your lab has been, it is very clearly mentioned. Suppose if you are offered 17 test parameters, but out of that 17, you may get the accreditation for 10 parameters only. Your assessor will satisfy, or auditor will, assessor is proper word, not auditor. That assessor will satisfy whatever the parameters you offered, he will cross check, he will see whether how you are inter-comparison, you are having the facility for inter-comparison. That within our organization, we are testing the same sample. Homogeneous material like metal. Suppose if I am having a 3 rods, TMT bar or plain carbon steel. So all 3 bars, one sent to Chennai, one sent to Calcutta, and one I have tested. And all 3 results will be within that parameter. Then they were conducting inter-laboratory testing. Means we are sending to sample to NABL authority, and they are sending to their accredited laboratory. So that Z score they will see. All this system, it is well defined. It is internationally accepted. Your certified product will not be tested again. Suppose if you are exporting material to Japan, they will not say that after consignment received, we will test, we will have opinion from our laboratories quality control, then we will accept. No. Once we have sent the certificate from here, from private accredited laboratory, they will see the certificate, and commitment of this laboratory is already there, and their acceptance will be on the basis of this. Such type of things are happening after accreditation. Now, whatever we are talking, all suppose experts are from laboratory, whether it is private, whether it is very small organization, very small laboratory, only tensile testing is conducting, but he is having the caliber at a par of very big organization personnel. Suppose if I am from government organization, you are from NECO, I am very big organization, you are lot of experience, you are conducting every day 200 tensile test bars. Suppose just think like this, and they are testing only 2 bars. But whatever even if they are testing 2 bars, their capability has been assessed. Whatever the 200 tests are conducting, the person, those who are institute at a par. So these benefits we are getting, and for that, this ISO 17025 is there. So once you have got this certification, so your caliber, your capability, your manpower, your machine, your building, sufficient space is there or not. Even railway, it happens by mishandling of the spring. It's made up of metal. Though it is painted, loading and unloading, they were throwing like anything. And suppose if thrown, or they were store inventory, not like a private, months together store we are having. So it was in the what you can say outskirts during rainy season. It is deep into water, something it will. So corrosive media is there. So thing, and after that, when they require that spring, they are going to use it. It was happening earlier. 20, 15 years, 10 years, 5 years back. After getting such type of certification, this, that, so many, so people getting, because throwing springs, though it is metallic, or rolling springs, though it is metallic, but once that paint is removed, we are getting the dent. Dent is the place where your corrosion will start, galvanic cell will formation, and again you are dipping in the rainy water. So automatically their fatigue will start when application of load during train running with all this your weight. So that time, though it is it should be there for 5, 10 years, 15 years, but it will break after fitting itself within 6 months. So such type of quality checks, all departments, all users are having. And because of this specification, testing, laboratories, accreditation of, then what is the difference between this accreditation of testing and calibration? So calibration is very stringent. Calibration instruments, once it is not working, and if you are repaired, you have to send it to only National Physical Laboratory. Nowadays, other calibration laboratories are there as per the agglomeration of your testing laboratories. But earlier, whatever happened, it is written in the specification. Once it is breakdown, means you have to take this instrument to, even after repairing. Yes, this type of things are there. Now people are very cautious, taking care of, experts are coming, everything has revised, but you can say that amended clauses are there. Next. So this, okay, accommodation, everything I have discussed. Next. This laboratory shall take into, next. Already covered. Laboratory shall use appropriate methods and procedure for all tests or calibration within its scope. Laboratory shall use test equipment requirement for correct performance of tests and calibrate all equipment used for test or calibration shall be calibrated before being put into service. And laboratory shall have procedure for estimating uncertainty. Very few people are knowing. Earlier, we were knowing, those who are now involved, it's a compulsion. But how to calculate the uncertainty? People, they were talking about the tolerance. Tolerance is something different and uncertainty of measurement is different. Now, all people, those who are involved in testing and calibration, they know they are having calculations, they are considering while offering the comments on failure or passing the component, they are taking into account this uncertainty of measurement. Laboratory shall have sampling plan and procedure. Laboratory shall have procedure for transportation, receipt, handling, protection, storage, and disposal of tests of calibration item. Laboratory shall be reported accurately, clearly, unambiguously, and objectively, opinion and interpretation of compliance, non-compliance of the results with requirement. Laboratory, next. Next. Okay. So here we have covered this. Now, next. Now, how many minutes? I will run now. 10 minutes only. Okay. So, basic things, characteristic, on the basis of characteristic, physical test, mechanical test, then how to evaluate the characteristic by conducting the test, and that particular mechanical test, how to calibrate the instruments, what is the importance of the calibration, means everything we have covered in ISO 17025. Once it just like a compulsion now, your laboratory will not run if you are not accredited. That's all. Means it's a compulsion. No need to explain anything about this one. Now it is understood. Once you have set up your laboratory, means you will go for ISO 17025, ISO IEC. Next. Now we will talk about the materials. First. So here I was telling about this engineering materials. Engineering materials are metals and non-metals. Metals means ferrous. Ferrous means iron, steel, pig iron, cast iron, wrought iron, copper, and alloy. Wrought iron. Okay. Then non-ferrous covers copper alloys, aluminum, zinc, tin, this, and rubber, plastic, your composite polymer. Okay. This is the classification of the materials. Next. Now, next. What? Alloys. Now, metals we have talked. There are metals, means ferrous metals as well as ferrous alloys, non-ferrous metals as well as alloys. Alloys means what? Ferrous base, and we are adding the alloying elements. Non-ferrous base means just if you will take an example of steel, it is an alloy of iron and carbon. Plain steel. Stainless steel, it is an alloy of ferrous as well as this carbon plus chrome, nickel, your copper and other ingredients. Means it will consider as a alloy. Same thing happen aluminum and its alloy. Aluminum plain, but you are not going to have that mechanical properties, wear resistance, this and that. To improve that properties, ductility, parent metal will give virgin metal. But addition of alloying elements as per your requirement, whatever the properties you want to require, that can be done either by heat treatment or by addition of alloying elements. Okay. Next. Ferrous. What is ferrous metal and ferrous? Okay. Next. Your ferrous alloy steel carbon is less than 2.1. If you see here carbon equilibrium diagram, you will get all idea. And carbon at what temperature peritectic reaction takes place, at what temperature eutectite takes place, at what temperature eutectic. Above 2.11% carbon, it is cast iron. Below 2.11% it is steel. Again, that steel means plain carbon steel. you will be having 0.77, means total microstructure will be perlitic. Less than 0.77, you will be having perlite plus ferrite. Above 77% of carbon, you will be having cementite plus perlite. At what temperature it will start austenitization? Above 727. From upper side, if you see your this perlite or ferrite, cementite, as per the carbon percentage, it will start transformation into austenite. For heat treatment, from that particular means 850, 820, when you are going to heat that one, and if you are going to quench that material, it will be hardening. Heat treatment. If you are going to slow cooling, it will be annealing. If you are going to cooling air, it will be normalizing. If your carbon is 0.1, but you want to have 0.4% carbon on case, so then you are going to have case hardening. Case hardening means for enrichment of carbon, you are going to have carburizing, nitriding, and carbonitriding. So you can have that how much depth it will be having the calculation, how much depth it can be given. Once on surface you will get the wear resistance. After hardening, this you have made the enrichment, carburizing. Again you have to heat treat, means hardening and then tempering to relieve the stresses. That sequence is going, means pore will be tough, your outer surface will be as per your end. Whatever you are talking about new material, na, all things have been taken care of by the metallic materials only. Yes. It is just like whatever the clothes we are wearing, as per the fashion we are giving the names. Otherwise, all were covering. All clothes are covering. Very simple. In the name of fashion and something, there should always keep on changing. There must be modernization. That otherwise no value in the life. Keep on changing always. Okay. So carburizing happens. Suppose your toughness is also should have more toughness. Means pore should have more toughness. And your step. So then there is a induction hardening, that is by flame hardening or electric alternating current or plasma also. All such type of things can be, means heat treatment can be given to steel. And as per your own requirement, as per your own specification, suppose if plain carbon steel is there, your properties will be something different. Hardness, this all parameters your mechanical test give. After heat treatment, you can have even in chemical also, you can change that chemical, means carbon, not other chemicals inherent that composition. So you are cast iron having this, it will start cast iron as well as heat treated cast iron means. In cast iron, if you are going to see the microstructure, graphite flakes will be there. Because of graphite flakes, damping capacity is there, but strength will not be there. If you want to have strength plus what you can say that plasticity, means percentage elongation of cast iron will be 0. Okay. But if you want to have 5% elongation, then you can change that cast iron into nodular cast iron. Graphite flakes, instead of line, if you are making ball nodule, so you can have elongation also. So that type of, earlier it was malleabilizing instead of rubber ball, what you can say, rosettes type of structure. So properties you have to, because of advancement in technology, parallelly new materials are coming. Metallurgists, they are innovating lot of things to stand by parallel. And all these materials, your definition, your requirement, 6 requirement are given. Sustainable development, so recyclable. All metal are recyclable. It can be reused. Pollution is not there. Means all 6 are satisfied. So such type of cast iron malleabilizing and your nodular cast iron ductility will come. Your align, nigh hard, wear resistance material. Lot of things from cast iron we are getting. The carbon percent greater than 2.1. Next 2.1. As per iron carbon diagram will give you all the picture, just like your tensile test graph, stress versus strain. So many properties you can evaluate, you can find out the significance of that particular stress. What is area covered by this, by the graph will be the resilience, full area covered by the toughness, at this particular yield point, this one, it should be exceed for your buckling, for rolling. So many things can be interpreted like this. Ferrous alloys can be broadly classified into steel, cast iron. Okay, next. Low carbon, high carbon, medium. That form iron carbon diagram up to 2%. Maximum 1.7 it is, but in iron carbon 2.11 it is given. Up to 1.7, this low carbon, medium carbon, high carbon, it is given. High alloy tools are you are using. The tool steel, family of tool steel. That may be made up of molybdenum, that may be made up of tungsten, main composition. High speed steel, your lathe machine tool. Yes. Stainless steel. Stainless steel will be there, ferritic, paralytic, as per the your matrix. Either austenity, your general this orthopedic surgeon, they are using 304, 316 L grade. 316 L grade molybdenum addition will be there. Your fluid of the body will not react with that one. Such type of yes. So that taken care of. Your martensity having a higher percentage of R1 comparative to your ferritic transformation, you can give by the treatment giving that one. So hardness will be more cutlery and other your utensils are manufactured by from ferritics and martensity, where hardness is much more important, means instruments by martensity, and your utensils. Sometimes you have seen that what you can say, utensils are getting cracked, so that nickel percentage are very less. Cost saving. In the market, they are telling this box tiffin 5 rupees, this one 10 rupees. Why we should go for 10? Why? Cost consideration. So there you will find costliest element is nickel. Yes. So they are not using that one. And next, carbon alloy, stainless steel, tool, die, cast iron, cast steel. We have discussed. Next, these can be classified in many ways. The basic classification, carbon grade, discussed. Next. These steels contain less than 25 L. This low, medium, they are talking about here in slide. Low, medium, and this one. Now this is low carbon. We have discussed already bridges, towers, support, columns, rise, building, pressure vessels. These materials are made up of low carbon. Means that is nothing but structural steel. IS 2062 is available for that one. IS 1875 we are using mostly IS specification. Compare what is this specification to have a common reference. They have made this specification, material specification. AISI there, DIN is there, JIS is there, Japanese, Ghost Russians is there, so SAE. So all these things, even for test procedure, ASTM is there. Your ASM material, they are talking about ASM material. Parallel. Now, Bureau of Indian Standard, they are also accepting as it is. Means an ISO, IC, they have given the permission. They can put the IS instead of ISO, IC. That rights has been given. Where no changes at all they have to make. That time they will write one IS also in addition to ISO. That much of things are happening. Common platform. Next, medium carbon steel. These are used for making camshaft, connecting rod, gear, piston rod, same thing. Heat treatment we have discussed already how we can change the properties. Next, high carbon steel, tool steel we have talked about. Stainless steel. Next, here summary it is given. Alloying elements are added to steel for many purposes. For what we are giving the heat treatment and this to improve the strength, to increase the hardenability, to improve wear and abrasion resistance, to improve oxidation and corrosion, to increase high temperature resistance, to increase the toughness with retaining strength. Next, these are the alloying elements. It is given carbide forming elements, graphitizing elements. Suppose if you want to have cast iron, we have to add these elements to have better graphitization. Otherwise, improper structure will also spoil your cast iron. Damping capacity will be very less. If you're in microstructure, big type of projects are there. C types are very big, thick flakes are there. E type distribution is there. Only we should have A type distribution. That much of control it is required. It will take care of this by graphitizing element. Austenite stabilizer, stainless steel. If you want to have authentic, so you have to take care of this. Nickel is the best stabilizer in nickel. If you want to have hard-filled steel, that is also austenitic steel, having much more what you can say for digging tools, crusher. All these are being made up of hard-filled steel. Means 1:10 ratio. 1 carbon, 10 manganese minimum. So for marine purpose also that. Otherwise, this chromium for stainless steel, that ratio is fixed. Carbon and chromium. If depletion of chromium and carbon takes place at a grain boundaries, it will start corrosion. And without any prior intimation, that particular job in which is in marine means seawater collapse. Without any prior intimation, it is called fatigue. Nothing but a fatigue. Yes. Okay. Ferrite stabilizers likewise. Next. Manganese, we have discussed this increased hardness, good ductility, capacity, wear resistance, ideal impact resisting. Next. Chromium, we have discussed for this. That means hardenability and strength is increased. Common steel having less than 2%. Common steel. Common means plain low alloy steel. But for specific purpose, if we are using this chromium in stainless steel, it is defined. Means this much of means for greater than 12.7 for ferritic, less than 12.7 that carbon and chromium combination. Next. 5 minutes are there now. I will cover all this. Okay. Nickel, same thing. Discuss next. Vanadium. So vanadium increases the strength without loss of ductility. Sometimes what happens, if we are going to improve one property, other property will drastically change. Yes. Right? So that is the relation, common thumb rule. But here, without any loss of ductility, by addition of vanadium, you can have that increase in strength property, means more strength you can achieve. Tungsten helps to form stable carbides, increase hot hardness. So what is hot hardness? Everybody knows, those who are using tools workshop. Right? Hot hardness means temperature will rise during machining, during turning, this and that. That tip of the tool should have that much of hardness even at that particular temperature. It is nothing but this parameter will be specified by the design engineer, that hot hardness should be this much. Okay, next. Next, allying elements one by one, it is written here that copper, this increases corrosion rate, reduces surface quality, silicon also same thing. Next. Boron. Boron is a very detrimental element. This is used for your machinery, but in terms of ppm 0.00 something will give the machinability. Okay, but above that, all other properties will be lost. Yes, brittleness will be there. You cannot, means ductile material will be converted into such type of things happen in construction TMT bar. That recycled scrap, some parts will come having better machinability and boron content, that will be added here while remelting, and your TMT bar will be having strength but no yield for. Means that is, yes, elongation will not be there, bend will not be there, rebend will not be there. Means you are not going to achieve that property. At a cost of that one, you are getting this. Next. So all these allying elements, again, same thing elaborated. Next. Effects of elements on steel. We are discussing about the alloying elements. Yes. Now all 25, 26 elements are there here in metal. So what is the particular effect of that element? Boron, calcium, carbon, cerium, chromium we are using as an alloying element. But calcium we are not using as an alloying element, as a deoxidizers or such type of things. But automatically it will improve one or the other property. So all this carbon, manganese, sulfur, phosphorus, silicon. For plain carbon steel, it is considered as an impurities. Yes, sir. It is not an allying elements. But for the solidification, for nucleation, just like an embryo formation in a human being, that one nuclei will start your impurity. That impurity will take care of solidification, progressive and directional solid. Without impurity, there will not be solidification of the metals. That nuclear formation must be there. So, and that too, again in metallurgy, these elements cannot be avoided. At the time of extraction, it will come in the percentage of 1, 2, 3, like this it will come. After reduction, decimal converters in Steel Authority of India Limited, they are using the technology. Earlier in railway also we were having the problem that parts per million, hydrogen embezzlement. We were talking about, suppose these rails before 1985, we were having that production. So all rail failure was because of this hydrogen. 6 parts per million, that time they could, I mean, retain that much. But now technology, vacuum degassing and lot of now 1.6 instead of 6, 1.5. That defect totally removed. Now rails are not failing due to that hydrogen embrittlement. So the statistic gives the information about this one, how we have switched over to new technology and what benefits we are getting out of that. Next. Copper, lead, manganese, molybdenum, we have discussed everything. Molybdenum, tungsten and vanadium, these are the elements we are using for the tool steel. Whether it is die for wire drawing, right? Or your hammer chisels, not hammer chisels, but common tiles, your reamers, and drillings, that drill bits. For that M series means molybdenum. And W series means tungsten. Like that for dyes also, H series and all it is different. Everybody knows about that one.
Next participant is asking about tell me about some cerium.
Cerium we are not going to cover here in metallurgy. Cerium.
Yeah, cerium is a separate topic.
So along he is talking, it is given here now. Earlier, you take earlier. Here, cerium.
Yeah.
Cerium. Control the shape of inclusions and improves the toughness in high strength, low alloy steel. It deoxidizes steel. This is cerium. But application, we are not going to discuss about that particular element. There you will find 90 to 95 metallic elements in the periodic table. But how many we are going to use here? Just like that specification, Bureau of Indian Standard, they have formalized and standardized 17,000 specification. But how many specification metallurgical department they are using, or they are having formulated 1700, not 1000, 1700. And how many compositions and alloys are in the market? 70,000 plus, as per my knowledge is concerned. So it is restricted here. Cerium plays a very important role in chemistry of the metal. That effects is giving. Next, any more question you take? No. Nickel, niobium, phosphorus, psyllium, silicon. Next. Already we have discussed this. Yes. You are going to get all these things. Tellurium, titanium. Here we have taken care of near about 25 elements are there. Alloying elements we were talking about during this lecture. At the most 7 to 8. Tungsten, molybdenum, vanadium, chromium, this, copper, this only. But these are the elements. It can be used for one or as a not alloying element, for deoxidizing, for other like this. Next. Tool steel and stainless steel already discussed. Next. Now non-ferrous will come. Next. High speed steel. This M series, S series, shock resisting dies we have discussed. Steel specification. Indian specification, how it is specified. And just like this FE E20. Indian specification. Or chemical composition just like C15. C denotes that percentage of next figure will give the percentage of carbon. This is stainless steel. Ferritic, they have arrow they have shown. Austenite is restricted to small region of the face. This much of austenitic stainless steel from this diagram. We can get the information. No need to have discussion, detailed discussion on this diagram. Diagram will take a lot of time. Next. Stainless steel, ferritic. This 304 316. Grades it is given. In market, they are using these terms. Right now, 403, something like this. Next. This is passivation layer and stainless steel. Why stainless steel? It is called stainless, means without stain. And how it comes just like a lizard. When that removed, again it will form. When it is removed by denting or something due to this layer in microns, again it will form. Just like aluminum, self-anodizing. Suppose some scratch is there, again it will get converted into Al2O3. So again that passivation will be there, taken care of corrosion, resistance to corrosion. Same thing happening here. It will form chromium oxides. Next. Austenitic, martensitic we have discussed. Next. This AISI also, how they are giving this designation, codification, it is given as per AISI. This cast iron we have discussed. Gray cast iron, this graphite flakes, everything details are given. Ductile iron edges, this because of this nodules and that matrix may be ferritic, matrix may be pearlitic, matrix may be martensitic. From that martensite you will get a more strength, but at a cost of elongation. As it is, if you are going to have a test, you are going to get a elongation. Cast iron, no elongation at all. But we can change the material in this fashion by heat treatment. Next. White iron, malleable iron. Next, ferrogates we have. Non-ferrous. Non-ferrous, aluminum alloys, copper alloys, nickel alloys, so on. But basically in our engineering field or day-to-day here, we have come across majority of brasses, bronzes, and aluminum where 4% copper we are using, that is precipitation hardening. From that precipitation, aluminum having the ductility and malleability. But we can improve the property just like a steel by precipitation hardening. Phases can be changed and it will act as a steel. So, so that aluminum alloys and brass. Brasses are so many types. It's nothing but a alloy of copper and zinc. But you will find Cartier brass. Name so many means so many actually. And bronzes, copper, zinc, tin. Addition of tin will give you the ringing sound, bale materials, so many things. It will come next. This why non-ferrous, lightweight, stiffness, high temperature, oxidation, corrosion resistance, biocompatibility, and thermal electrical conductiveness. Aluminum and its magnesium, this titanium, copper, zinc, and nickel and its alloys. Next, aluminum we have this again step by step. These are the alloying elements. Aluminum can be used in the form of as cast, as rolled, as wrought. Means this one heat treatable alloy. You can just 4% copper addition duralumin that will give you the properties of steel. You can improve the properties at par of steel. And non-heat treatable alloys are also there. These are the series. And mostly your automobile industries, aluminum silicon alloys, they are using LM series. LM5 and 10, that is magnesium series. LM6 and 11. LM5 and 10 magnesium. And 6 and 11 silicon. These two series they are using mostly. So recycle scrap, again that is making the adulteration. These are the components, 2-3 components we have mentioned. That your tank now in railway they are using aluminum tank, axle box. Next, radiator fan blades. Next, this copper, all the oxidized copper and arsenic, this and that. Now arsenic is a detrimental element, poisonous, toxic. So majority of these compositions are reduced. Application of this, because recycled scrap there should not be arsenic. So first type of alloys are minimizing. Next, application of this copper. Next, copper alloy, brasses, bronzes, and cupronickel. Yeah. Brasses, zinc, lead, tin. Now these names are there. Gilding metal, Cartier brass, admiralty, aluminum brass, basis brass. That same example I have discussed. 70-30.
70-30 and 60-70.
Yes, that is called basis brass. At low cost, you are going to get 70-30 properties. Okay, next. Next. Molten metal lead, phosphor bronze, bronzes. Next. Aluminum bronze, silicon bronze. This addition of elements means whatever the elements we are adding, and I am talking about 70,000 plus number. Only making the changes in the composition as per your own requirement. R&D people will try to find out the solution as per the requirement of design engineer. He is going to introduce Mercedes car, and if he wants to have that particular type of component, properties of cast iron, properties of plastic, properties of elastomer, whatever the things he will consider, and he will say, I want this. So how we are going to make a composition, it will be decided. Time is over.
You already were explained.
Okay, thank you.
Actually, the second speaker, he has also joined. And he has a session from 8 to 9:30.
Okay, I have to restrict because you said now that time is limit.
No, next session is from
will be started.
Okay.
immediately after you. The speaker is also joined.
So, friends, here I am concluding my session. If you are having any questions, I am ready to answer it. And if you are benefited this one, let me know. I will reduce this time, and I will make, if I will get the opportunity in future. So it was means after retirement, after 2 years, I was having this more and more whatever enthusiasm is eager to speak, eager to share my experience with all these people. So for me, it no limit for. Okay, thank you.
As already in his introduction, we have seen his vast experience, and really we are very privileged to hear him. Thank you, Shri Vasant Meharkure, sir, for this wonderful and informative session on need of materials on sustainable development. Thank you very much. Two more eminent persons from ASM International Pune chapter are with us, Mr. Udyan Pathak